In question 3, we're told under certain circumstances a photon moving through a material can interact with the nucleus of an atom of the material to produce an electron and a positron. In part 1 we need to name this process. Well, this is known as pair production. In part 2 we need to give a reason why the photon could not produce a single electron instead of an electron and a positron. Well, this would break the law of conservation of charge, as the photon is neutral and an electron has a charge of -e, the charge on the electron. In part 3 we need to make use of the data and formula booklet to show that the minimum energy of the photon required for this process is 1.02 mega electron volts. Well, the rest mass of an electron from the formula sheet is 0.51 MeV, so to produce an electron and a positron, the positron having the same mass as the electron, the minimum energy would be 2 times 0.51 MeV, which is 1.02 MeV. In 4, we're told photons whose wavelength exceeds a certain value will not cause the process. We need to find the maximum wavelength for the process to occur, giving our answer to an appropriate number of significant figures. Well, for this we can use the equation photon energy is equal to the Planck constant times the speed of light in a vacuum over the wavelength. Rearranging for the wavelength, putting in the values for the Planck constant, the speed of light in a vacuum, our energy in electron volts times 10 to the 6 is their mega electron volts, converting to joules by multiplying by the charge on the electron, gives a wavelength of 1.22 times 10 to the minus 12 meters. In part 5 we need to explain what will happen to the positron produced by the interaction. Well, this will soon meet an electron. They will annihilate each other, producing 2 gamma photons.